The accident at 3 Mile Island was caused by a major design flaw, and it all started in the March of 1979. At early 4 in the morning, near Harrisburg, Pennsylvania, a series of mechanical errors occurred at the 3 Mile Island nuclear power station, which then resulted in an accident that greatly affected the utility industry. This mistake included struck valves, misread gauges, and poor decisions, which eventually led to a partial meltdown of the reactor core, which then released some radioactive gases into the atmosphere. However, this accident did not affect people's health seriously, but what it did cause was the public to fear nuclear power stations for the fears of meltdowns in the United States for years to come. And it also led to the immediate shutdown of several factory plants in the area.
So, what is nuclear power generation? Nuclear power stations use fuel called uranium, a relatively common material. Energy is released from uranium when an atom is split by a neutron. The uranium atom is split into two, and as this happens, energy is released in the form of radiation and heat. This nuclear reaction is called the fission process. In a nuclear power station, the uranium is first formed into pellets and then transferred into long rods. The uranium rods are kept cool by submerging them in water. When they are removed from the water, a nuclear reaction takes place causing heat. The amount of heat required is controlled by raising and lowering the rods. If more heat is required, the rods are raised further out of the water, and if less is needed, they lower further into it. For an unknown reason, the feed water pump stopped working. Without this pump, the turbine does not have enough water to remove the heat from the steam generator. When this happened, the control rod automatically dropped into the reactor, stopping the fission process. However, the radioactive fission product still produced heat, so the temperature and pressure started to rise. To reduce the pressures, the valve on the pressurizer opened. When the pressures in the pressurizer dropped to a precise value, the valve was supposed to close. It did not. The control panel had an indicator that showed the valve to be closed, but there was no way to determine that the valve was actually closed. This water flowed into a drain tank. The plant lost tons of cool water, which absorbed the enormous heat produced by 150 tons of uranium that lie buried in the heart of the Plant Unit 2 nuclear reactors. When the feed pump failed, the emergency feed pump should have turned on to keep the turbine water flowing. That pump was tested 42 hours prior was functional. However, to perform the test, workers must close the valve, perform the test, then open the valve. Apparently, the worker forgot to open the valve, so the emergency water did not flow. Now the reactors were losing water and getting hotter. With a loss of water, the pressure dropped. When the pressure dropped, some of the water in the reactor turned to steam. This resulted in two major consequences. First, it forced water into pressurizer and filled it completely. And second, the steam rather than water surrounded some of the reactor fuel. Steam does not conduct heat as well as water, so the fuel pellet heated up. In case of an accident, a nuclear power plant has tanks of water with pumps that can quickly introduce water to cool the reactor. One of these automatically started. This was noted by operator, but then they looked at the indicator for pressurizer. This indicator was telling them that the pressurizer was full of water. was because of the steam in the reactor's course area. The full pressurized mean that the operators cannot control the pressures, so they turned off the entering water. Now, the situation was getting worse. About 100 minutes after the accident started, steam bubbles appeared in the coolant pumps, causing them to vibrate. Fearing a complete failure of this pump, the operator turned them off, with no water flowing into the reactors and water and steam escaping the reactors. Large portions of the reactor core became uncovered, with no water to remove the heat. The fuel pellet started to melt, resulting in partial meltdown. Finally, one operator surveyed the data and concluded that the valve pressurizers were open. So at 6:18 a.m., they closed the valve and then introduced water into the reactors, thus ending the immediate emergency. However, between the time that operator shut off the pumps and when the valve was closed, the core was uncovered, enough to cause some fuel to melt. In fact, at the time of the accident, nobody thought that a major portions of the fuel melted. When the reactor was opened months later, they were surprised to find that about 60% of the core actually melted. While the reactor core was melting, the hot zirconium that held the fuel was reacting with the water. This chemical reaction produced hydrogen gas, which is combustible. Some of the hydrogen gas escaped from the reactor and into the the containment building. The operators were unaware of the presence of hydrogens until something ignited the hydrogens about 2 p.m. The burn lasted for 6 to 8 seconds, but did no damage to any system in the building. However, the reactor vessel still contained hydrogens, but nobody seemed to address this problem in more serious problem. When somebody gave it some thought 2 days later, the great fear was that the hydrogens might explode, causing a breach of reactor vessels and maybe of the containment building. Once the presence of hydrogens was verified, the hydrogens were sent through neutralizers, and by the fourth day, most of the hydrogens was gone. Actually, the fear of an explosion was unfounded. To burn, hydrogens must combine with oxygen, but no oxygen was present in the reactor's vessel. However, the fear of an explosion caused many of the public evacuate the area around 3 Miles Island.
During the incident at 3 Mile Island, no one is exactly sure why the incident happened in the first place. However, what is known is that the pipes and their backups both weren't working, and the gauges for the pipes didn't show that the pressure was rising, and this eventually led to the meltdown since the gauges didn't show that the pipes were overflowing with pressure until the very last minute. What I'm about to explain to you is some results that could have been possible, that could have led to the possible breakdown at 3 Mile Island. The pipes at 3 Mile Island ran with the help of motors and valves, which were supervised by trained maintenance workers. However, the accident at 3 Mile Island occurred due to a flaw in design, and this eventually led to the malfunction in the gauges and the surge or flow pipes and pumps. The pumps were designed to withstand a certain limit of hydraulic loading, which is the time and overflow rate of a water flow, and it's also meant to withstand the limit of power requirements. However, these design requirements are often exceeded by the actual requirements of the pipes in many real-life situations. The problem with this was that at 3 Mile Island, it could have been caused by any of these two limits or both of them at all, which would happen when they were surpassed. One possible malfunction was that the pipe could have been caused by a water hammer, which is when the flow of water is suddenly stopped or has a sudden change in velocity, and this will result in an immediate spike in water pressure. When a water hammer occurs, it could eventually result in motor failure, which could also lead to why the gauges didn't show any problem till the very last minute. Another possible cause of failure would be due to a shock load, which is when water has a sudden stop or accelerates suddenly. It's like when you fall from a high building or you jump off from a high altitude. The fall won't kill you. It will be the sudden change in velocity that does kill you. It's similar to this. This is what a shock load is. And since water has a low viscosity, which is the semi-fluid consistency due to the internal friction allowing water to move smoothly across surfaces, shock loads can lead to extensive wear and bearing/gauge failure. And this could have been another reason why the gauges didn't show anything until the very last minute. No one is actually sure why it happened, but these are possible causes of failure. And then this chart right here shows several pressures that can be withstand within the design components, as well as the volume that the pipes are able to withstand. Even though the cause of accident at 3 Mile Island is unknown, we can find a resolution to prevent this from happening in the future. One of the main issues that was sent to the shutdown of 3 Mile Island during the incident was caused by a failure in the distribution pipes. Since the surge pump and their backup both stopped working, this prevented water from cooling the tank, and this eventually resulted in a meltdown due to the sudden spike in pressure while the gauges reported nothing wrong. One of the failure that could have led to the surge pipes from stopped working is that they could have been caused when the valves were closed, and this permanent closure could have eventually led to a sudden rise in pressure. But this also could have been caused when the pressure could have been compressed over a very long time and it slowly built up, and this might have been the very reason why the gauges didn't show nothing wrong on the monitors. In this picture right here, it shows how the quench tank wasn't able to send water to heat the reactor core because the valve had closed. And while the water was steaming up away from the reactor core, not being able to heat it up, the water evaporated due to the heat rising, which eventually wouldn't be able to do nothing because it will never be able to reach the reactor core. And this pressure also could have been calculated using the following equation with using H as your pressure. And then aside from this, normally the pipe's valve is set to have a static pressure, which is where the elevation pressure is equivalent to the pressure produced by water pressure from the flow of water. As shown in the picture here, by having more, the water is rising and slowing due to the open air valve, and while air is rushing while the water is rising, and this causes a cancellation in pressure, and this would allow for an equilibrium. By having more maintenance on the valves or the pipes during a monthly or semi-monthly schedule, this will be able to prevent an accident similarly from happening at 3 Mile Island, from what happened at 3 Mile Island from reoccurring again. And this could also be prevented by having a trained regulator or a daily worker who would keep the pressure at an equilibrium by allowing the pressure to drop, which would then cause the water to rise. But then as soon as the water reaches a preferred water level, the valve would be open so that pressure stabilizes, and thus will have a constant water flow rate with the pipes. Right here, it shows that the water since the valve is closed, pressure is rising, which will allow the water to move up, but it has nowhere to go. Meanwhile, until we open the valve, and then the water will stabilize due to the pressure, and then eventually we'll have a constant flow of water. Aside from this resolution, we could also be able to prevent another nuclear power plant meltdown by using new mechanisms to evaluate operating experience and to ensure that necessity changes are implemented into the regulatory program. And improved inspection, we also need an improved inspection and evaluation system for operation reactors so that we have a constant check that everything is A-OK and no problem will occur in the future. We will also need some strong measures to strengthen the on-site technical capability and management of utilities at reactor sites when the need arises, including a new philosophy and new programs for improved operator training during their education so that when the time comes for them, they are trained and ready to deal with the problem at hand. We could also have qualified engineer supervisors with intimate knowledge of the plant, as they will be part of the on-site supervisory management chain on every reactor operating shift. That way, someone is also always keeping check on the workers to make sure that everything is in order and no problem will occur. We could also have substantial changes in the bases used to review the safety of reactor designs, including the application of quantitative risk assessment methods to potential accident sequences in order to augment the current design basis accident approach. Aside from this, we could also have a direct line from that we could have from the 3 Mile Island to every plant site in the United States, or just connect every power plant that we have so that not only ties and voice communication links are accessed, but it will also allow these individuals to talk to their counterparts on site as soon as a problem has, so everybody will be able to help each other and less problems will be able to be had, or if the problem arises, they'll be able to fix quickly due to the help from everybody across the United States. With this, we'll be able to run annihilation as an analyzer and turn it over and attempt to characterize what the most important parts of the safety system that we should be concerned with. Another thing that we could do is have less to do with hardware engineering, but have more to do with human attitudes toward technology. Complex technology work best when they are backed up by skepticism and checking, not bravado, not confidence, and that way nothing can really go wrong. Complaints humorado are recipes for surprises, and very nasty ones at that. And then, as our technology is advanced, and as our power to wipe ourselves increases, it is vital that we use our wisdom to increase at least a faster rate of our knowledge and wisdom, so that when we learn from our mistakes, we don't repeat them again. Which is why, when these accidents occur, we have to be sure that we make sure none of it happens again by analyzing what happened, what could have happened, and how we can fix it. Thank you for listening to our 3 Mile Island report. Any questions?